Okay, so here for the next two questions, be sure to start with the formula. Put in the change and then follow the math. So on the planet Zorgon, the acceleration due to gravity is that of Earth. So by what factor would the time period of a pendulum change? So if we write the formula for time period of a pendulum, it's 2 pi times the square root of the length of the pendulum over the acceleration due to gravity. And it's saying here that the gravity is half as much. So we're talking about the gravity being half, or acceleration due to gravity being half of what it normally is. Now 2 pi stays the same no matter what, so we're going to leave that out of the formula. Now since this is length over acceleration due to gravity over 2, we can actually rewrite this as L times 2 over acceleration due to gravity. Now since the length and the acceleration due to gravity, these variables right here are not changing, we're just halving the acceleration, which we're showing here. This is going to change by a factor of the square root of 2. Or we can plug that into our calculators, and it would be a factor of 1.14. Sorry, 1.41. Alright, so the period would get 1.41 times bigger, or get bigger by a factor of that much. Now, by what factor would the period of a spring mass system change on Zorgon? Well, time period for a spring mass system is 2 pi times the square root of the mass over the spring constant. Now, since we're not changing the mass stays the same no matter what. The only thing we're changing is the acceleration due to gravity, and that's not any part of that formula. There is no change. No delta in our time period for a spring mass system. Now, a pendulum is moved to planet Pedronium, where the acceleration due to gravity is 1/8 the strength of the Earth. Now be careful, what is the change in frequency? Remember, frequency is 1 divided by the time period. So whatever we get for our time period, it's 1 over that, whatever that change is. So 2 pi, because that's a constant, we're going to leave that out. Length over acceleration due to gravity, but now it's 1/8, so gravity divided by 8, which we can rewrite this as L times 8 over acceleration due to gravity. Now since these two things are basically staying the same, it's really the square root of 8. And that's how much the time period is going to be affected by. Now the frequency is going to be affected by 1 over the square root of 8. So that will be by a factor of 0.354. So frequency is going to get smaller by a factor of 0.354.